Hello, hello guys, it's good to see you again. How have you been?
Hi.
Sticker, gallery, pin my video. Hello, can you hear my voice loud and clear?
Yes, Miss.
Yes,
Yes?
Master.
Okay, let me change the audio setup. Okay, now repeat again. Can you hear my voice?
Much better. Much better.
Excellent. Because I have to set off the 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 um, the headset sound before to do that. Okay. As soon as you can see, guys, today we are changing once again the my classroom. So for that reason, we have different setups. Well, actually, for this day home, this is going to be my new class, where at least for seventh graders class. Okay. Today, what we're going to learn? Well, actually, we're going to prepare a little review according to the law of the exponents and monomials, right? I know you studied
We're
this
already
law
starting. This is the starting of second partial, right?
exactly. The
Okay.
first topic, the first lesson of the second quarter. No new lesson for you, at least for a few changes in the law of the exponents. Okay, we were to study the eighth law of the exponents and how we can apply them. Obviously, the the question says, or the name of the topic says, law of exponents and monomials. We're supposed to learn how to add, subtract, or in this case, multiply and divide monomials. But actually, in the last quarter, we learned how to apply the distributive. We are doing a distributive property. Well, in this case, that will be a child's play that you, at the moment, you're going to apply this law of exponents. Okay, what we're going to do today? First of all, I'm going to explain every law of exponents. And after that, we're going to solving a few problems that we're supposed to apply. Okay, so the first law of exponents. What does that mean? In simple method words, that means a multiplication with the same base. Multiplication of power with the same base. At the moment, we're going to multiply the variables. That's what I'm saying. We're going to copy the base and we're going to add the powers. This is what does that mean? The rule number one. I'm going to copy over here. For example, if I have a and the n power times a to the n power is a n plus n. For example, if we want to multiply x at the fifth power, multiply x at the seventh power, what does that mean? I'm going to copy the letter x and add the powers. I mean, 5 plus 7 will be 12. This is the meaning of the rule number one. Multiplication of power with the same base. Copy the base and add the powers. Okay, understood, Lorena. Thanks for letting me know. Okay, that was the rule number one. What is the explanation of the rule number two? Is the opposite. The rule number two establish if we have a n power divided by a n power, you're going to copy the base and subtract the powers. For example, if we have a w of the 15th power over w at the third power, what are we going to do? Well, according for the explanation of this rule, I'm going to copy the base, okay, in this case, the letter W, and okay, hold on, hold on. Can you hear my voice, guys? Yes?
Yes.
Okay,
Yes.
okay. We're going to copy the base, and how about with the powers? We have to subtract. So 15 minus 3 will be
12.
12. Perfect. 12. So the answer will be W have the 12 power. This is the meaning of the rule number one and the rule number two. Okay, now I'm going to give you an explanation of the rule number three with the rule number seven. Why? the rule number 3 and rules over 7, both are the same. What will be the difference? One of them, if we have a fraction, and another one, if we have a whole number. The name of that rule, or that rule number 3 and 7, is power of power. In Spanish means potencia de potencia. What happened in this situation? For example, rule number 3 says, okay, we have a fraction, a over b elevated to n power. That means am over bm. Okay. For example, if I had a fraction like x fifth power over y third power elevated at 4. Elevated at 4. By the way, Diego, can you see perfectly well the whiteboard? Diego, can you see perfectly well the Bible? Okay.
It's Pamela, Master.
No, no, no. I know because Diego is over here. He's with me. That's why I'm asking for him. Okay.
Okay.
Now, what we have to do? Power of power means I'm going to copy the fraction. Okay. And how about with the exponents? That means I'm going to multiply the exponents. I mean, for example, copy the letter x over y, right? And this number 4 will multiply the number 5 and also the number 3. 4 times 5 will be equal
20.
20. Okay, that will be x 20 power. And 4 times 3,
12.
12. And this is going to be the solution set of the rule number 3. The name of this rule is power of power because we're going to write a fraction and the powers will be multiplied. And the number 7, just to explain you already, the number 7 is the same rule in the number 3. What is the difference? Because we can have a whole number, a at the end, elevated the n power will be a and n. For example, if I have a seat at the third power, elevated the sixth power, what I have to do? I'm going to copy the base. And how about with their powers? I'm going to multiply them. Okay, so 6 times 3 will be
18.
18. So as soon as you can see, the rule number 3 and the rule number 7, we're talking about the same. The difference is the number 3, just in case you have a fractions. And the number 7, just in case you have how to say that, whole number. All right. Are you following into this far?
Can you
Yes.
do another one of
Yes,
3?
Master.
Excuse me?
Can you do another one of 3?
Which one? And which one?
3.
This is number 3,
Number
3 times 6. 3 times
No,
6,
number
16.
3.
No, like the
Ah,
exercise.
The law.
the law number 3,
Like in
power.
another example. It's
Yeah, I'll do it. Another example. Just hold on. I'm just explaining what does that means. Well, another example, the rule number 3. For example, if you have a little bit complex, x at the third power, y at the 2 power, over c at the 4 power, elevated at the 4 power. Okay? Can you see that one? All right. So what are we going to do? We have the fractions, okay? We're going to copy the base. I mean the letters. X, Y, over C. Okay? Because we have 3 letters. How about with the powers? Simple. Every power must be multiplied by the exterior power. I mean, this number 4 will be multiplied by 3, will be multiplied by 2, and also multiplied by 4. So simply words, 4 times 3 will be equal
12.
12.
12.
Okay, will be x 12 power. Then another one, 4 times 2,
8.
8. Okay, 8. And finally, 4 times 4,
16.
16. And that's it. The name of this rule, number 3, and the rule number 7 is power of power, because you are going to copy the base and the powers multiply them. Understood?
Yes.
All right then.
Yes.
Now, the rule number 4, the rule number 4 with the rule number 8 is the same. Uh, okay, I'll do it, Andre. Don't worry about it. I'll do it. In the rule number 4 with the rule number 7, we're talking about the same rule. This is the rule of the negative powers. The number 4 is just in case you have an entire fraction. For example, A over B at the negative power, at the negative n power. If you want to transform a negative power into positive power, the only thing that you have to do is write in the opposite direction this fraction. I mean, if you have A over B at the negative n power, there will be B over
B
M,
over A
A,
equals
sorry,
the positive power.
exactly. This is going to be a positive power. So this is the minute situation. For example, if I have 5x over 2, if I have x over 2 elevated the negative 2 power, okay? If you really want to know what will be the answer to this situation, first of all, we have to rewrite this fraction in opposite order. I mean, 2 over 5x elevated at the second power, right? Because we are changing the position, we are turning on this in opposite direction, this fraction, and we are changing the sign. But this is not will be the answer because we have a fraction elevated a power, so we can return applying the rule number 3. First of all, we applying the rule 4, and after that, the rule number 3. What will be equal? Will be equal 2 at the second power over 5 at the second power and x at the second power. Because 2, 5, and x, we have a number 1 imaginary number power. So would you like to tell me what is the value 2 at the second power?
Uh, 4.
4, right? Perfect. 4 over 5 second power,
Uh, 25.
25. 4 over 25, 25 what? X squared. And this is going to be the solution set of this rule. This happens, this is a rule, negative powers with fractions, okay? Now, what happened if we have whole numbers? This is going to be in the rule number 8. The rule number 8, if we have x fifth power elevated at the negative 1. Just want to give you a number, okay? First of all, before to apply the rule number 8, before to apply the rule number 8, what we have to do, we have the rule number 7, right? Power
Yes.
of power. Copy the base and multiply their powers. That means I'm going to have x at the negative fifth power. And now, because we don't want to working with negative powers, it's time to apply the rule number 8. 8 and the negative n power, that means will be given by 1 over x of the fifth power. And this is going to be the solution set of the rule number 8. In the whole numbers rules, the negative exponent or powers means if you have a negative power located in the numerator, I mean upward, to be positive passes to downward. And if you have a negative power downward, passes to be positive upward, writing the, how to say that, the monomial in opposite directions. This is the meaning of the rule number 4 and the rule number 8. Okay? Understood until this far?
Yes.
Yes.
Okay. Understood? Perfect. Now, I'm going to explain the rule number 6. Quickly mode. In the rule number 6, I'm writing over here, not be complicated. It's the most simple rule that you're going to get. Any base elevated at the 0 power without exception will be 1. Without exception. It doesn't matter if we're talking about whole number, if we're talking about the fraction, if we're talking about variables, if we're talking about numbers, always will be 1. I could have a complex problem like a 3x fifth power y third z at the 6th power over 5 6 y2 z3 and the entire expression elevated at the 0 power. Oh, you're going to see what a mess because we have a division, we have powers, but all of them that will be elevated at the 0 power, right? Out the power of 0. You don't need to complicate that one because the postulate number 6 says any base, it doesn't matter what complex it is, and this base will be elevated at the 0 power. The answer, without exception, will be 1. Understood? Understood?
Yes.
Yes.
Without doubt, without exception. We have the most complex monomial, in that case, elevated to 0 power. The answer will be 1. Okay? So we are studying the rule 1, 2, 3, 4, 6, 7, and 8. We're skipping the rule number 5 because this is the chosen one, the last one, the most beautiful rules of them. Because this is the newest part. Because I'm pretty sure you studied at least with these 8 rules, at least 6 or 7 rules you studied since 4th, 5th, and 6th grade, right? But then rule number 5, this is the rule of the radical expressions. What does that mean? This is the how we can write a radical expression into exponent. For example, according for the rule number 5, if we're saying well, a root, n root of n power, an power. I'm saying n root because the letter n could be square root when n equals 2, could be cubic root when n equals 3, it could be fifth root when n equals 5, and so on, okay? And according for this rule, check this out. The only thing that we have to do is copy the base and this radical sign, I mean the letter N, passes to divide the power of n of m. So to transform this radical expression to power, always the subindex will divide the power of the base, and we got the radical expression. For example, if I have the square or the cubic root of 5 at the 2 power. Okay? I'm not asking for solve this cubic root. I'm just asking for write this expression in exponential form. What does that mean? I'm going to copy the number 5, and according for this problem will be 2 divided by 3. Another example, if I have the square root of x over y. Okay? Remember, we have to rewrite this expression into an exponential form, all right? X and y, we have a number 1 imaginary number, okay? And you don't see any number, okay, because this is square root. The letter n will be 2. On see it or not seeing the number 2 over here, always will be number 2, at least if I write like a number 3, number 4, 5, 6, 7, and 8. So what we have to do, x and y, remember, both has a power of 1. Okay, because x is one power, y is one power, and because we have the imaginary number 2 over here, okay, this is going to be parentheses x over y elevated at 1/2. I'll do it, Andre. Just hold on. Hold on. I'll do it. Example, the number 1 and 6. Hold on. Okay. So, but this is going to be the final answer? Yes or no?
Yes.
Are you sure about that?
Wait.
I think that no, master.
No, this is not, because we're applying the rule number 5. But if you see, we have a fraction, and this fraction elevated at outside power, right? This is going to be the rule number 3. Rule number 3, power of power. Okay, this 1/2 will affect the letter X and also the letter Y. So the final answer, sorry, will be X Y over Y 1/2. And this is going to be the answer
The
of
answer.
the problem number 5. Okay, because we are applying the rule number 5, and after that, at the same time, the rule number 3. This is an introduction, because after that, I'm going to teach you how to simplify monomials, applying the rules of the powers. And after that, I know you know how to calculate the square root of the number. Okay, I know you can do that, but I'm going to teach you how to write an answer in simple radical form. I mean, for example, if I ask you what will be the value of the square root of the, sorry, the square root of the number 8, okay? You know the process to obtain the answer in decimal numbers, okay? But applying the rule of powers, you're going to learn to write the square root of the number 8 will be equal to the product between 2 and the square root of the number 2. This is the name of that situation, is simple radical form. But you're going to learn a little bit later. All right? Don't worry about it. Yes, Mister?
I
Yep. Don't worry. We're going to learn how to do that in a few lessons later. And we're going to learn how to write a number in scientific notation and the scientific notation in number. These skills, this ability will be useful in the classes like, uh, sorry, in science. It's so useful in the scientific notation in science. And also, it will be useful in class like physics, but I'm not saying the physics like the Mr. Osorio. No, 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 no. I'm saying the elementary physics. This is a class and I'm provided to the students in 10 and 11th grade. It's the fusion between uh, the science class with math class. Okay. Let's going to do another example, just a request. Like, for example, we're going to apply the rules of the exponent. Could be rule number 1, rule number 2, and rule number 3, and so on, okay? That's why the lesson is law of exponents and monomials, okay? So the example number 1 says, simplify the following expressions. Okay, simplify the following expressions. For example, in the letter A, we have the product between 5x6 power, y3 z2 power over 2x cubed yz multiplying by 2x y2 power z4 power divided by x cubed y cubed z at the fifth power. Okay, Obviously, what operation do we have? We have a product, right? Yes or no? Hello?
Yes.
Well,
Yes.
what will be the big deal of this situation? We have to combine this product. I mean, solve the product applying the law of the exponents. For example, I know you learn how to apply distributive property, but in this case, this is not distributive property because we don't have adding or subtracting numbers. Okay, just have to multiply the situation. So what we have to do, please be careful with the numbers. 5 times 2 will be
Uh,
10.
10.
10, right? 10, 10. Okay, 10. And because I'm going to multiply the variables, the first thing that we have to do is copy the variables. X, Y, Z, okay? And because we are multiplying, remember the rule number 1, product of powers with the same base. Copy the base and we're
And
going
add the
to
power.
add the powers. For that reason, X will be given as what power?
9.
7 power, because 6, and this is how elevated at 1 power will be 7. Why? Why? This is number 3, and this is number 2. 3 plus 2
5.
will be 5, right? So
Yes.
we're going to copy the number 5. And the next one, 2 plus 4,
6.
6. Perfect. Over. This is, we are not seeing a whole number over here, but this is a number 1 imaginary number. So 2 times 1 will be
2.
exactly 2 times 1 will be 2. And we're going to repeat the process. I'm going to copy the variables X, Y, and Z. And we're going to add their powers. Remember, this is third power, this is third power. So 3 plus 3 will be
6.
6. Excellent. 6. Y, 1 plus 3
4.
plus 1 plus 3 is 4. Exactly. Remember, we don't want to multiply. We are adding. Okay, and finally, 1 plus 5 will
6.
be 6. Perfect. 6. Okay, we are combined. We are combining that product. Okay, now it's time to simplify if we can. For example, how about with the numbers? Can we divide 10 divided by 2? Yes or no?
Ye-
Of
Yes.
course we can, right? 10 divided by 2?
5.
5.
5. Okay, we're going to write the number 5. And how about with the letters? Remember, we have a division, right? Rule number 2. We're going to copy the base, X, Y, and Z, and we have to subtract the powers, okay? Because it's the rule number 2. So 7 over here, 6 downward, 7 minus 6 will be
1.
1. Perfect. So we can leave like a letter X or X at 1 power is the same. How about Y? We have 5 and we have 4. 5 minus 4,
1.
1. So we can leave like a Y. And finally, 6 minus 6,
0.
0. Okay, 0. I have a question for you. Is this the final answer? Or
No.
we are
No.
missing another thing? Check the
Yes.
rules. Check the rules of the powers. I'm going, excuse me?
The answer is 1.
Every power that has 0,
Exact.
it's 1.
The rule number 6, right? Every power who has a 0, every base who has 0 power, the answer will
It's
be
1.
1. For that reason, the answer of this problem will be 5x, y. You don't need to put the number 1 because you know 5 times 1 will be 5. And this is going to be the solution set of this problem. Okay? This is how we can apply the, the rules of the powers. We're going to do another example. We are combining rule number 1 with rule number 3, and at the end, rule number 6. 3 rules in one single example. Okay, let's do it. Another example. Letter B. We have 3x 2y negative third power 6 over x c at the 2 power elevated at the second power multiplying by 2x y c at the negative 2 over x at the negative 3 y 2 c c at the third power elevated 3. We are creating a new one, right? So guys, what do you think? What do you think will be the first thing that we have to do in this case? What do you think we have to do? We have to multiply first the fractions or applying the power of powers rule. What do you think? If you don't remember, I'm going to move the camera a little bit to the left side. Hey, what happened? Oh, and then the variables. Yeah, eso. This is the rule of the powers. Okay. So remember, rule number 3, we have a fraction elevated one singular power. We are copying the fraction in the basis, and all of them will affect with their powers. Okay. So according for that situation, this letter B turns a nightmare. I know there's a nightmare. And we have to multiply first the powers before to apply the product of their fractions. I mean, you have to multiply, for example, 3 at the second power because the 3 had number 1 power. X 2 times 2 will be 4. Okay? Y negative 3 times 2 will be negative 6. And Z 6 times 2 will be 12. Are you following me? Are you
Yeah.
following me? All right.
Yes.
Over,
Yes.
over. X squared Z at the what power? 4. Okay?
2 for you.
Yeah, will be 4 because remember, in this case, I'm not adding. In this case, I'm multiplying the powers. That's why the name, power of power. And I'll do it the same situation with another one. 2 at the third power, x third power, y third power, z at the negative 6 power over x at the negative 9 power, y 2 power, z at the third, mistake, 6 and 9. Okay? Okay? Because remember, this number 3 multiplying 33, 2, and 3. Understood at this part? Understood?
Yes.
Right. Now,
Yes.
before to
Yes.
multiplying, remember we have a whole numbers, 3 second power. Okay, we have to simplify that expression before to do that. 3 second power, 9, x4, y the negative 6, z 12 over x squared z 4 power multiplying by 2 at third power, this is not going to be 6. No, no, no. It's 3 times the number 2. 2 times 2 times 2 will be 2 times 2 times
Uh,
2, 8, right?
8.
8.
8,
8.
6. Oh, yeah.
8x 3 power, y 3 power, 6, negative 6 power over x at the negative 9 power, y 6 power, z at the 9 power. Okay? Now, because we are simplifying the power of power rules, now we're going to proceed to multiply their fractions in a straight line, upward with down, upward, and downward with downward. Okay, just to combine it in one singular operation. So what does that mean? 9 times 8 will be 72, right?
72.
I'm going to copy the x, y, and z. And remember, we're supposed to copy the base and add the powers. For example, the first one, 4 plus 3, 4 plus 3,
Um,
7, right?
7.
7.
Exactly, 7. Okay, check this out. This is negative. Negative 6 plus 3, negative 6 plus 3 will be
Negative 3.
Negative 2.
negative 3, right? Negative 3. Even though I know
Uh,
we're supposed to add up because we have a negative. If you're positive, negative 6 plus 3 will be negative 3. Okay, negative 3.
Ah, I thought, no, I thought another thing.
Mhm. And 12 plus negative 6 or 12 minus 6,
6.
6. Okay, we copy the number 6. Over. 2. We're going to copy x, y, and z. Okay, 2 minus 9. 2 minus 9,
7.
negative 7. Be careful with the
Ah,
sign.
negative 7.
Negative 7. There's no letter y over here, so we're going to copy the letters, the number 6. And 4 plus 9
Uh,
will
13.
be 13, right?
Yes.
13. Okay, we are combined the fractions. Okay. Before to simplify, my dear students, before to simplify this monomial, right? What we have to do, we don't want to working with negative powers. Okay, so we're supposed to apply that negative power rule. I'm going to explain what does that means, because what are the bases who has negative power? The basis who has negative power is x negative 7 and y at the negative 3. Okay, only these two variables have negative powers. Okay, what we have to do, so to rewriting this expression using positive powers is simple. Don't forget about it. This golden rule that I'm going to tell you. If the negative power is located over to pass to be positive, you're going to grind in the downward position. And if the negative power at the beginning was in downward position, to transform in positive, that will be located over. Okay, so let's check this out. We had the number 72. We had the first x7 power. And if you see this negative 7, x at the negative 7 power, that's located downward, right? So if you want to transform this variable in positive, moves over. And I'm going to copy x at the 7 power.
So we're
Okay,
gonna switch places.
exactly. Switch places is the right word I'm looking for. So y at the 6 power, get it over here. And because we have y at the negative third power, this is over, that's going to be downward. Thanks for help me with the right word that I'm looking for. Switch places. This is the word that I'm looking for. And because the rest of the numbers has positive powers, there's no, we don't need to switch places, only copy all of them, okay? Seat had the 6 and 13, okay? But however, we cannot simplify yet because we have a multiplication of power with the same base. Copy the base and add their powers. What does that mean? That means we're going to have 72 x at what power? You know,
7.
7. No, 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 no.
Oh, no, no, no.
Copy the base and add the powers.
14.
7,
What?
14.
Yes.
14. And see the 6 power over. Same happen over here. I'm going to copy y. But y at what
Why
power?
9?
A 9
The
power.
power
Okay?
of nth power.
And
Oh,
finally, seed of the 13 power. Okay? Just to simplify the expression, we cannot simplify y with seed. X with y, right? But we
yes.
can simplify seed.
Y with
Okay?
Y and X.
So
Ah,
while
and
we
Z.
cannot simplify this one because of difference, okay? However, the letter C, yes, we can do that. Well, in this case, if you don't want to working with negative powers, it's simple to do it. Remember, we're supposed to copy the base and subtract the powers, right? So to avoid to obtain negative result, we can obtain the difference between 13 minus 6. 13 minus 6 is
And
7.
7.
7,
Yeah,
right?
7.
So if you want to avoid to write C elevated the negative 7, it's simple. I'm going to copy the letter C in the place in the originally was located the biggest one. So simplementary words, we have 72 x 14 power over
Yeah,
y, sorry, 9 power, and C, that's going to be 7.
7.
Why I copy over here? Because the difference between these two ones, the bigger one was located downward at the originally. And that's why we can have the answer onto this situation, okay? And this is going to be, my dear students, the solution set of the problem number, yeah, sorry, of the problem number 2.
Can you send a photo of the one of the loss? Like the photo of what you write of the loss. It's because
I'll
he
do it.
didn't write
I'll do
one
it
of
right
them.
now.
Because
Just
it's
hold
already
on.
time and we have an exam at the
Yeah, I know, I
another
know, I know, I
period.
know. I know.
And you're going to send a photo to the chat, mister?
I'll do it right
I-
now. Just hold on. Give me 1 second. Here we go, the first picture. And this is going to be the second one. All right. Thank you so much, guys, for your attendance. Have a great and wonderful day. Okay.
Bye, mister.
Bye-bye. Take care of yourself.